distance formula. I know you remember this. The next one is midpoint formula. And the third one, which is not a review, is the equation of the circle. By the way, is a circle a function? No, it cannot be a function. By the vertical line test is not a function. Very good. Okay, so let's look at 2 points. Here's a point, I'm going to call it A. Here's another point, I'm going to call it B. The coordinates of A are x1, comma, y1. And of course, what do you think I'm going to use for B? Very good, of course. Makes sense. And I'm going to connect the two with a line segment. And I would like to determine the distance between A and B. Okay. I would like to form a right triangle. And I would like to use the Pythagorean Theorem.
You're getting too fancy.
Theorem, not for you. And but of course I need to determine this length, and I need to determine this length. So the Pythagorean theorem, please do not say a squared equals b squared plus c squared. That's not correct. You have to identify what is it, what is what. So it's the hypotenuse squared, which is the longest side, equals leg 1 squared plus leg 2 squared. Yes. So this is the Pythagorean theorem. The sum of the squares of the legs equals the longest side squared, which is the hypotenuse. Okay. Now, as long as I can determine, so the hypotenuse squared will be d squared, of course. But now, is there any way I can measure this? So I know that this is x2 right here. I know that this is x1 right here. This is x1 and this is x2. So how much is this? Very good. Plus. In the same way, this is y1 and this is y2. I need to determine this length. How much is that? Very good. So this is the equation of the distance. However, we don't really like to have d squared. We're going to write d. What do I have to write on the other side? Because if I forget, I mess up the problem. No. What do I have when I take square roots? What do I always do?
Plus minus.
Right. However, this particular situation, I will not write minus. Can anyone explain why all the time we write plus or minus, but not now?
Because there's actually a triangle.
Because it's a distance. Yes. x2 minus x1 squared plus y2 minus y1 squared. This is the distance formula. Can I simplify it any further? Can I say the square root of this plus the square root of this? Good, I'm happy you didn't say anything, at least that. Absolutely not, because the square root of a sum cannot be simplified. So the square root of 9 plus 4 does not equal the square root of 9 plus the square root of 4. So this is it. This is the square root of 13, and this is 3 plus 2. The square root of 13 does not equal 3 plus 2.
That's an example.
That's a counterexample in which I was showing you that you were correct by not saying go ahead and simplify, because we cannot. So you cannot write the square root of this plus the square root of this. Not allowed. Okay, so also there is a point right in the middle. That's why it's denoted by M, that divides or bisects, we say, the entire segment into two equal parts. So M is the midpoint, and the coordinates of the midpoint, it's easy to remember as the average. The average of x1 and x2, the average means the sum over 2 because there are two numbers, and y1 plus y2 divided by 2 for the same reason. So now let's illustrate this with two ordered pairs. So please give me two ordered pairs, any ordered pairs you want, so we can determine the distance and determine the midpoint. And then we will look at the last item on the list for today. Which one? 3, 7 is perfect. And some negative, throw in a negative in there anywhere you want. Negative 2 and 5, perfect. So in order to find the distance, please, I highly recommend rewrite the formula, x2 minus x1 squared plus y2 minus y1 squared. On a test or final, yes, Joseph. On a test or final exam, you will never write that the distance is the square root of negative 47, correct? Why? What type of number is this no matter what once it's squared? What type of number is this no matter what once it's squared? And you are adding two positive numbers. Can you ever write this? Thank you very much. Go ahead.
Is that m is m equal to x1 plus x2 or just
It's the sum of the x values divided by 2, comma, the y values divided by 2, the sum of the y values divided by 2.
so it's m is equals to, right?
No. So when we write a point, we don't write equals. So it's like this one. I didn't write b equals. I'm not saying it's incorrect, but we don't write b equals. Very good. So you already know my habits. Use them if they work for you. Disregard them if they don't. So this is x1, y1, and this is x2, y2. I like to write these numbers underneath. So I have a negative 2 and a positive 3, and I have a 5 and a positive 7. And now let's do this together. How much is negative 2 minus 3? And negative 5 squared? Very good. The square root of 25 plus. How much is 5 minus 7? And negative 2 squared? So therefore, the distance is the square root of, that's it. Finally, please give me the coordinates of the midpoint. Please add up the x values. Divide by 2. Please add up the y values. 12 divided by 2. That's it. That's all we needed to do. I'm hoping that between now and Wednesday, you're going to work on some examples and bring more examples to class. We can go back and do more, but I'd like to discuss the equation of the circle. Okay, so assume that this is a circle. You can say it's not. I will have to agree. It's approximately. It has a center. The center, by convention, the coordinates of the center are denoted by h, comma k. Lowercase h, comma, lowercase k. Of course, h is the x coordinate and k is the y coordinate. Any point on the circle, let's denote it by a, has coordinates x, comma, y. It has to have an x and has to have a y. Now, please tell me, what is this? The distance between the center of the circle and any point on the circumference of the circle. It's the radius. Very good. If I say or write this, would you accept? I claim that the distance AC is the same with the radius. Would you agree? Of course. So I'm going to write R on the other side, but I want you to give me the distance so I can put it on the left-hand side. Obviously, it's the square root, right? We just used the formula a few minutes ago. Square root of what? Very good. X minus h. What? Squared plus The plus has to be there.
Y minus K
Y minus k.
parentheses square.
Very good. Okay. I'm going to square both sides. Now I don't want square roots. When I square the left-hand side, what do I get? Itself, right? And I have to square the right-hand side as well. What do I get? Very good. This is the equation of the circle. How did we get it? From what? From a previous formula that we just reviewed. And what was that formula? The distance formula. Awesome. In this section, there are only 3 types of problems for us, for the equation of the circle. 3 types. Type number 1. And now I'm going to pick from your book. And this is the last section of chapter 2. Okay, we are asked in problem 34 on page 332, forgive me. The center is given as 2, -1, and the radius is 4. So the center is 2, -1, and the radius is 4. We're asked to find or present the equation of the circle that passes through, or that has this center 2, -1, and has a radius of 4. Okay, when you're ready, please dictate.
Vx
Very good.
minus
Yes.
2
Awesome.
squared plus,
Perfect.
y
Yes.
minus plus 1
Awesome.
squared equals radius 4 squared,
Which is?
60.
That's it. That's the first type of problem. We are given the center and the radius. We're asked to create the equation. The second type of problem is slightly more difficult. And the third one is obviously the most difficult. Okay, here it is, 46. What I would like to do before we move on to the second type, I would like to graph the circle. Which circle? This one. So let's graph it. I always start with the center. The center is 2, -1. This is the center. I know that the radius is 4 units. I will create 4 points, east-west, north-south, 4 units away from the center. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is the circle. If you say it's not perfect, I'm going to say it's far from being perfect. I would have to agree. So this is 2, -1. Now, if somebody asks you what is the domain of this relation, it's not a function, what would be the domain? So this is yes, very good. -2
to 6.
to 6. And what is the range? This is at -2. Very good. -5.
3.
Very good. Awesome. It is, especially from my graph. I agree. Good point. Okay, 46. In 46, we're asked, this is the other way around. We are given the equation. And we're asked to determine the center, determine the radius, and possibly graph it. So, what is the center and what is the radius for number 46? Let's start with the radius because it's the easiest.
5.
Indeed, no question. The radius is 5 of this circle. But what will be the center? And always remember this: 2, -1. -2, +1. Very good. Very good. Any questions? Okay, last type of problem. Let's say 53. X squared plus y squared plus 6x plus 2y plus 6 equals 0. The question is this a circle? The answer is I have no clue. If I manage to present it somehow like this, then I'll say yes. But if I cannot present all this in this format, I'll say no. If this number is 0, what kind of circle is that with a radius of 0? It's just a point. If this number is -3, I'll say no way. There is no radius. Square root of -3 doesn't exist. It's not a real number. So this has to be a positive number, not 0. And this has to be a completed square with x plus a completed square with y equals a number. That's what this means. So some time ago when we started chapter 2 and we looked at quadratic equations, we said these are 4 methods, but one of them is a waste of time. Which one? That I said I will never, ever apply. It alone cannot solve the problem anyway, but it's useful for something else at the end of chapter 2, not for solving quadratic equations. Which one is it? Completed square, of course, that's what I just said. A completed square with x plus a completed square with y equals a number that is positive. Good. So then, the middle coefficient is 6. We divide it by 2 and we get, and we squared 3 and we get, very good. So all these 3 are here. This binomial squared will be this, this plus this. What?
Wait, say that again.
This binomial squared will be 1, 2, 3 terms.
Plus 3.
Very good. Now the other one. This one. Middle coefficient. Divided by 2. Square 1. Very good. So now this, this, and this are right here. This binomial squared is 1, 2, 3 terms. Yes? Yes? Exactly, what we squared to get this. There is nothing else that I squared to get 1, right? Very good. So that's perfect. Now I'm left with this. I have 10 on one side and I'm bringing a -6. So what is left on the right-hand side? Indeed. Now I'm asking myself, does this resemble this? Yes, so it's definitely a circle. Now let's identify the radius and the center. Cool. Of course, the radius is 2. Very good. Let's graph it. They may ask us to graph it. So -3, -1, 1, 2, 3, 1 is this point. I create 4 points. How many units away from the center? Say it again. Yes, that's why it goes to -3. X plus 3 will go to -3.
On the graph.
Oh, I'm so sorry. Yes, thank you. Daydreaming. Thank you. My apologies, of course. My apologies. So that's correct. It's -3, -1. Yes. -3 for x, -1 for y. Perfect. Thank you. Can get away with anything. I don't want to. Thank you. My apologies. So 2 points, 2 points, 2 points, 2 points. So this is the graph of the circle centered at -3, -1 with a radius of 2. Any questions for me? We have time for one more. Which type? Would you like from the last one?
The last.
Very good. Now you understand why I said that this is the method for something else, not for solving quadratic equations. I know you're tired, but is it a yes or a no?
Yes.
Thank you. I appreciate it. Okay, here it is. Let's say 57. X squared plus y squared plus 8x minus 2y minus 8 equals 0. The question is this the equation of a circle? And the answer is, we have no clue. If we manage to present it in an equation, in the equation of the circle form, then it's yes. If we cannot, then it's no. So let's work on x squared. What will we add to both sides?
16.
So it's 8 divided by 2, which is 4. And we divide it by 2, we get 4, and we square it. So it's 16. So we have something x squared, 8x, and 16 in here.
X plus 4.
Of course. So now we work on y. The middle coefficient is? It's -2 divided by 2 is -1. -1 squared is, again, plus 1. So this and this and this, plus, do not forget the sign between the two expressions.
Y plus 1.
Careful. It was minus. Yes, y minus 1. And now let's see what is left. All these are gone. The -8 moves to the other side as a +8. And we have a 16 plus 1, which is 17. Very good. Equals 25. Perfect. So now, final question. Is this the equation of a circle? Does it represent a circle? Yes, because it's a sum of two complete squares, one with x and one with y. The number on the right-hand side is not 0, and it's not a negative number. So therefore, we can identify the center
4 negative.
for -4 and +1, and the radius is 5. So if you'd like to graph it, if we are asked to graph it, we'll graph it. So -4, +1, and 5 units all the way. 5 units here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I got to 4 points, good enough for a non-perfect graph.
How do you get -4 and 1?
Because remember, it's x minus h. So I compare to x minus h squared plus y minus k squared equals r squared. So k must be 1, but h must be -4
Oh.
because of the negative.
Okay.
Better?
Mm-hmm.
Very good.